What if the next global superpower is not decided by oil, nuclear weapons, or artificial intelligence, but by a beam of energy sent from space? Imagine a machine floating 36,000 kilometers above Earth, a solar station so large it could stretch nearly a kilometer wide, locked in orbit, drinking sunlight that never sets. No night, no clouds, no storms, no borders. Then it turns that sunlight into electricity and sends it back to Earth as an invisible microwave beam. To one country, it could mean unlimited clean power. To another, it could look like control from orbit. A beam that can power a city could also make governments nervous. Because the first nation to control space-based solar may not just control a new source of energy. It may control the high ground above civilization itself. And that race has already begun. For most of human history, we hunted power on the ground. We burned wood, dug coal from the earth, drilled into ancient seas, and set them on fire. Then we learned to split the atom. Then we covered deserts with solar panels. But every energy source on Earth has a weakness. Solar power dies at night. Clouds block it, seasons weaken it, storms interrupt it. And even the largest solar farms only capture a small fraction of what the sun gives us. But above the atmosphere, everything changes. In orbit, there are no clouds, no weather, and no air to scatter the light. A solar satellite in the right orbit could face the sun almost continuously, 24 hours a day, 365 days a year. Catch that sunlight, convert it into electricity, and beam it down. Suddenly, humanity has something it has chased for generations: clean power that does not sleep. For decades, this sounded like science fiction. Isaac Asimov imagined it in 1941. NASA studied it in the 1970s. Then the idea was pushed aside. Too expensive, too heavy, too difficult. The dream was simple. The technology was not. You would need enormous solar arrays in space. You would need lightweight structures that could survive radiation, micrometeoroids, and decades in orbit. You would need rockets powerful enough to launch the pieces. And you would need a safe way to send electricity from space back to Earth. For years, that last part was the barrier. Then, in 2023, something changed. A small experiment built by Caltech, called MAPLE, flew into orbit aboard a spacecraft. Inside, it was a flexible array of microwave transmitters. The system powered on, aimed itself, and demonstrated the wireless transfer of power in space. It was not a power plant. It was not enough energy to run a city. It was barely a whisper. But the message was enormous. The basic idea worked. A beam of energy could be shaped, controlled, and sent without wires. A door that had been closed for decades had opened. And while America experimented, China began building. In Chongqing, in a district called Bishan, Chinese engineers developed a massive ground testing facility for one purpose: receiving power beamed from space. Their ambition is clear. First, small demonstrations, then megawatt-scale systems. Eventually, a gigawatt-class orbital power station. A solar array nearly a kilometer wide, hanging high above Earth, collecting sunlight nonstop and sending energy down to a receiver field below. One Chinese rocket scientist compared it to building another Three Gorges Dam, but above the Earth. And that comparison matters, because this is not just about electricity. It is about power in every meaning of the word. A country that controls space-based solar would not depend on fuel shipments. It would not fear blockades. It would not wait for the weather. It would own an energy source floating beyond borders, above politics, above oceans, above pipelines. That is why the race is growing. The United States is studying it. China is pursuing it. Japan has worked on it for years. The United Kingdom and Europe are exploring it too. Because the first nation to build a working orbital power station may not just create a new energy industry. It may create a new kind of strategic dominance. And that is where the dream becomes complicated. A satellite that can beam power to one place could raise questions about control, security, and trust. The same technology that restores electricity after a disaster could also make governments uneasy. The same beam that powers a city could become a symbol of influence. The same orbital station that promises clean energy could force the world to ask who gets to control power from above. Even if the beam is designed to be safe, the concern will remain. Who controls it? Who regulates it? Who decides where the power goes? And what happens if something fails? The engineering questions are just as enormous. Can a structure almost a kilometer wide be assembled in orbit? Can it survive decades of radiation, debris, and thermal stress? Can microwave beams pass safely through the atmosphere? Can aircraft, wildlife, satellites, and people below be protected? Can the system be made cheap enough to compete with power plants on Earth? No one has all the answers yet. But something important has changed. The experiments are no longer fantasy. The rockets are getting bigger. The materials are getting lighter. The electronics are getting smarter. And the cost of reaching orbit is falling. What once looked impossible now looks difficult. And difficult is where civilization begins. Every great energy age started this way. Fire was dangerous, coal was dirty, oil was hard to reach, nuclear power was terrifying. Solar and wind were once dismissed as too weak to matter. Now humanity is looking upward again, not to worship the sun, not only to study it, but to harvest it. A civilization that spent 10,000 years staring at the sky may finally be preparing to plug itself into space. Above the clouds, above the storms, above the darkness, the first faint beam has already touched the ground. The age of orbital power has begun. The only question now is simple. Whose hand will hold the switch? So what do you think? Clean energy breakthrough or power too dangerous to control? Comment your take and follow Stellarscope for more.